Hello guys, welcome back to another AIME problem solution video. Today we can do a question here, and as always, let's start off by first reading the question. So, find the number of integer values of k in the closed interval -500 to 500 inclusive, for which the equation log kx equals 2 log x plus 2 has exactly one real solution. Now, we need to look at some key points here, which is just that this part, one real solution, and we'll be using this later on. Now, let's first write the domain for k and x. So, our domain is going to be that kx is going to have to be bigger than 0 for this to be a real number, and x plus 2 is also going to have to be bigger than 0. So now let's start writing some equations. Now we can see that log kx equals to 2 log x plus 2 as they've given us. So I'll write that down really quickly. Now, because the 2 is in front of the log, we can multiply this in here, which turns into log x plus 2 squared. Now, from this, we can then remove the log in front, and we receive kx, which should equal to x plus 2 squared. Further simplifying, we get x squared plus 4x plus 4. Now I'm going to move the kx over, and now we receive a quadratic equation, x squared plus 4x minus kx plus 4. Now we're going to be doing some casework really quickly. Now we can see that from this we can write out the derivative. So this would be equal to x squared plus 4 minus k times x plus 4, which equal to 0. So derivative is going to be equal to 4 minus k squared minus 16, which after expanding is equal to k squared minus 8k, or k minus 8. And for this to be real, we need this to be bigger than 0. Right, so this means that k times k minus 8 is going to be bigger than or equal to 0. Sorry. Now our first case is that we have exactly one real solution. So in other words, there's just one solution to this problem. And from this, we can see that k is going to have to be equal to either 0 or 8. However, there's a problem. Now, if k is equal to 0, this would go past our domain here, which is that kx should be bigger than 0. But if k is equal to 0, this does not satisfy our domain. So k equals 0 is not allowed. However, k equals 8 works. So our first value is going to be that k is going to equal to 8. Now, this is our first case. Now, our second case is that we have two solutions. However, one does not satisfy our domain, and one does, leaving hence one real solution. So from this, let's go back to our quadratic formula, and we can write it out. So k minus 4, positive negative k squared minus 8k, I'll write that for now, divided by 2. Now, since as I said before, the derivative is this, and this should be bigger than 0, as this was the equals 0 case. So we're on a second case now, which is this one. We can draw out a simple number line right here, and write out the two zeros, so 0 and 8. Now we can do a small number line by plugging in some numbers. Now, if we were to plug in a number like 1, we would see that the result would be negative. So I'm going to put a negative in between here, and for everything else, it would be a positive and positive. So from here, we can see that if the number of k is below 0, it's going to be this result is going to be positive. If it's not, it's going to be negative, and so on. So from this, we can see that k is going to have to be smaller than 0, or k is going to be bigger than 8. So we now have two more cases. However, we can eliminate one right now. Now, if k would be equal to 8, and we plug it into here, it's pretty obvious to see that both of our solutions would be positive. However, we can only have exactly one real solution, so 1. So in other words, if k is bigger than 8, both of our solutions will be positive, and we can't have this. So we're not going to consider this. So we're going to be considering k is smaller than 0. And from this, we write out this equation. So x is going to equal to k minus 4. For this case, we'll write plus instead of minus, plus square root k squared minus 8k divided by 2. And going back to our domain here, since we know that k is going to be smaller than 0, we can obviously see that this is going to be correct, as x is going to be negative. So from this, we can also write out that x plus 2, which is going back to our domain, should be bigger than 0. Now we can substitute x equals this number, this sort of equation here into here to receive k minus 4 plus k squared minus 8k is n squared, by the way, divided by 2 is going to be bigger than negative 2, and by further simplifying, we can finally receive k squared minus 8k is going to be bigger than negative k. Since in this case we have k is going to be smaller than 0, we know that k is going to be negative. So both sides of these is going to be positive. So from this, we can square it and get rid of the square root here, and finally receive k squared minus 8k is going to be bigger than k squared. With k, we move the k squared over, and we can finally receive 8k is going to be negative 8k is going to be bigger than 0, or 8k is smaller than 0, which can be simplified to k smaller than 0. So in this case, x is satisfied, and we do have one real solution as it matches our domain. Now let's go back to our second case, which is that x is going to equal to same thing as before. However, it's going to be minus the square root k squared minus 8k. Then from this, you're going to repeat the same steps we did here before, and I'll just skip past this to not waste time for the sake of the video. We finally receive k minus 4 minus square root k squared minus 8k should be bigger than negative 2. I thought I had the divide by 2 here, and then obviously we multiply both sides by 2 and move the k minus 4 over to finally receive k should be smaller than square root k squared and minus 8k, and you see that this is always going to be true, as I said before, k is going to be smaller than 0 or it's going to be negative, so we can see that square root is obviously going to be positive, and k here is negative, so this will always be true. So in other words, if k is smaller than 0, we will always have at least one real solution for one of the x's. And obviously, we're going back to our first case, we have k equals 8. So here we have our k should be equal to 8, and then negative 1, negative 2, negative 3, all the way down to negative 500. So the answer should be 500 plus 1, or 501. So the answer to the problem is 501. Thank you guys for listening. If you've any other solved problem, please let me know down below in the comments. Thank you guys for listening. Bye.